Earth. The cradle of humanity throughout our existence. But it won't be forever.
All it would take would be one giant meteorite to wipe us off the face of the Earth.
It's not just meteors. Our planet will change.
Our planet could freeze over, or it could heat up.
And our sun will eventually die.
We are actually near the end of habitability of Earth.
To survive in this universe, we need an insurance policy. To colonize other worlds.
Having multiple planets which are colonized is really in our interest for our own survival.
So, can we find a new home in the galaxy? Can we find Earth 2.0? For centuries, we only knew of the handful of planets in our own solar system. Now, astronomers are finding thousands of new worlds around alien stars, exoplanets.
We are discovering exoplanets by the bucketful. There are as many planets out there as there are stars, and there are hundreds of billions of stars in the galaxy.
But out of billions of exoplanets, are there any that could offer new opportunities for humanity to thrive and provide sanctuary in a dangerous universe? Is there an Earth 2.0?
Is Earth 2.0 out there? That will be truly amazing.
August 2016. Astronomers announced that Earth 2.0 could be closer than anyone ever expected. A planet orbiting the Sun's nearest stellar neighbor, the red dwarf, Proxima Centauri.
So it turns out that our nearest star neighbor has an exoplanet. It's only about 4 light years away, so that means that it's actually potentially possible for us to get there and to explore it.
Scientists named the planet after the star, Proxima Centauri b, or Proxima b for short. A world that appears to be a lot like Earth.
From the way it's tugging on the star, Proxima Centauri, we know that it has 1.3 times the Earth's mass, but it's roughly the same size as the Earth.
Of the exoplanets we know about, most are uninhabitable gas giants, like Jupiter. Proxima b is a rare find, an Earth-sized planet. But an Earth-sized planet might not be Earth-like. A true second Earth must also be the right distance from its star.
The habitable zone, or some people call it the Goldilocks region, is a distance away from the star where you're not so close where you're going to burn up and evaporate all of your liquids, and you're not so far away where you're frigid and cold. So it's that special region where it's just right.
Does Proxima b lie in this region? Could it have liquid water?
Proxima Centauri b orbits its star once every 11.2 days. So compare that to the Earth, which goes around the Sun once every 365 days. That's because the planet is much, much closer to the star than the Earth is to the Sun.
Earth orbits 93 million miles from the Sun. Proxima b orbits 20 times closer, under 5 million miles from its star.
You might think that Proxima b should be, really a fried world, a burnt-out husk, if you will.
But Proxima b's sun is very different than ours. At just over 5,000 degrees Fahrenheit, it's half as hot and roughly 8 times smaller. An M-class red dwarf star.
An M dwarf, the Proxima b is around, is much less bright, much less hot. So you can orbit much closer to that star and be at the same temperature that we are here on Earth.
Proxima b's tight orbit around the red dwarf could make the planet habitable. But it would be very different from Earth. The star dominates the sky, lighting any oceans and mountains with an alien red glow.
So Proxima b may be the Earth 2.0 that we've been looking for.
But in 2017, the dim red dwarf star erupts in a way that's unlike anything we've seen before. Blasting the planet with radiation. A mega flare.
They're like solar flares, but they can be much more powerful. In fact, they can outshine the star itself.
Our sun releases powerful solar flares when its magnetic field becomes tangled. But the mega flare is 10 times stronger than our sun's strongest flares.
On an M-dwarf star, that magnetic field can get a lot more tangled than on our own sun. That means that when a flare happens, it can release a lot more energy.
Scientists believe that megaflares like this are planet killers. Radiation tears the atmosphere from the planet. And these megaflares hit Proxima b roughly once every year.
Red dwarf stars are incredibly temperamental. They are not good parents to their planets. So if Proxima b did have an atmosphere at one point, it would have been stripped away by one of these violent outbursts,
leaving Proxima b dangerously exposed to space.
An atmosphere dampens the temperature gradients between light and shadow. So in sunlight, it is just burning hot. But right next door in a shadow, it is freezing cold.
Without an atmosphere, Proxima b would be a barren wasteland, blasted by intense radiation from its star, completely uninhabitable.
Proxima b, our perhaps best shot at finding Earth 2.0 so far, is actually a dried out husk of a world that has lost its atmosphere, maybe lost any water that it also harbored, simply by being that close to its parent star.
Proxima b may be the nearest exoplanet, but it's not the only option. The future of humanity may lie in an incredible star system just 40 light years away.
We've just found a really exciting system where there's not just one chance to have a new Earth, but 7.
In an unforgiving galaxy, finding Earth 2.0 could be the difference between extinction and survival.
It's a pretty wild place out there. Our planet's not going to be here forever, and it would be wonderful if we could find a place like it that we could live.
The future of humanity lies on an alien exoplanet. The question is, where? 2016. Astronomers scanned the skies with the new Transiting Planets and Planetesimals Small Telescope, or TRAPPIST. They look for the flickering of a star, caused by the silhouette of a planet.
The planet can pass in front of the disk of its star once per orbit, causing a little mini eclipse, a little dimming temporarily in the light of the star.
Scientists spot the dimming of a nearby red dwarf star just 40 light-years from Earth. The first alien system detected by the telescope, the incredible TRAPPIST-1 system.
The TRAPPIST-1 discovery was a really great bang for our buck, in a sense, because we found 7 exoplanets all at once.
But are any of these 7 planets actually habitable?
With the worlds of the TRAPPIST system, there's probably a range of climates. The innermost ones are probably very hot. You might even be looking at lava worlds. Farther away, they're probably worlds of ice.
But the middle planets, D, E, and F, are all prime candidates.
It's exciting to think that 3 of the planets orbiting TRAPPIST-1 are in the habitable zone, are at the right distance from that star to have liquid water on their surface.
And one planet stands out as a new Earth, orbiting just 2.7 million miles from the star, TRAPPIST-1e.
The composition of TRAPPIST-1e suggests that it could have a pretty significant iron core, kind of like the Earth does. There's a potential there for a very powerful magnetic field.
Like Earth, TRAPPIST-1e could host a protective magnetic field, deflecting the harsh solar winds and powerful outbursts that strip away atmospheres.
So a magnetic field is a good thing. It's a kind of a protection from the evil forces of the star that you're orbiting around.
And unlike Proxima Centauri, the TRAPPIST-1 star appears unusually quiet.
TRAPPIST-1 is actually a very old, much calmer star and doesn't undergo a lot of these huge flares like Proxima Centauri does.
And so it's a somewhat perhaps better system to look for an Earth-like planet, an Earth 2.0.
The data suggests that TRAPPIST-1e could have vast oceans, a protective atmosphere, and habitable temperatures. But living here would be nothing like living on Earth.
The thing to keep in mind about the TRAPPIST system is that it's very unlike our own. The planets are much closer in. So because they're closer in, their orbits are faster and smaller.
On TRAPPIST-1e, an entire year takes just 6 Earth days.
Can you imagine you're just basically tearing your calendar days off day after day after day really quickly? Your birthday would be today and then tomorrow. Happy birthday again! Wedding anniversaries, you're constantly forgetting your wedding anniversary. And it would be hard.
And on this strange and alien world, explorers would witness sights unlike anything seen before.
In a lot of ways, it really is sort of a science fiction sky, the kind of things that are envisioned in movies.
You could look up and see the other planets in your sky, much like how we can see our own moon. You could physically resolve features on the surface, such as continents, with your own eyes.
But could this planet be too good to be true?
So we could have a potentially habitable planet that's really close to its star, but other issues arise when you have a solar system that's that compressed. And one of those is the potential for tidal locking.
Orbiting just a few million miles from the star, TRAPPIST-1e is likely tidally locked, with one side facing the star forever.
So you could imagine a situation where, gosh, it's constant day, and it might just produce something that's like a scorched earth, kind of like what we see behind me. But on the other side, it is constant night. And so in that case, it might just be like a frozen wasteland.
And TRAPPIST-1e's problems get even more extreme.
If you have a permanent day side and a permanent night side, the night side of the planet is going to get so cold that everything just freezes out, including the atmosphere.
The gases of TRAPPIST-1e's atmosphere could freeze into solid ice on the frigid night side of the planet. And the gases on the day side burn away. The atmosphere thins and eventually disappears. And TRAPPIST-1e ends up completely inhospitable.
So even though we found maybe a perfect planet around a star, the type of star and where it's orbiting can have a really important effect as to whether or not that planet might be habitable.
Despite its apparent potential, our future is not in the TRAPPIST-1 system. The search for truly Earth-like planets continues.
In the TRAPPIST-1 system, we find a very Earth-like world, but the star is orbiting is not very Sun-like. So what we should be looking for, perhaps, is an Earth-like planet around a Sun-like star.
To find Earth 2.0, we need a Sun 2.0. The Milky Way, home to hundreds of billions of stars, ranging from dim, explosive red dwarfs to short-lived blazing giants. But in the middle are stars like our Sun.
Strictly speaking, if we really want Earth 2.0, we need to look for planets around stars like our Sun.
Stars like our Sun are calm and stable, with long lives. And the habitable zone lies far enough away that planets avoid tidal locking. We stand a much better chance of colonizing a planet around a Sun-like star.
We're hunting for planets in the habitable zone of stars like our own Sun, and we have found worlds there.
Worlds like Kepler 452b, an exoplanet 1,800 light-years away, orbiting the same type of star as our Sun.
You really couldn't ask for a more Earth-like orbit around the star. The year is about 385 days. We're 365 days. This really is very much like the Earth.
The planet orbits its star at roughly the same distance as the Earth orbits the Sun, and could be very much like home.
Kepler 452b is in the habitable zone of its star. So if there is liquid water there, there could be oceans and lakes and rivers and streams and blue skies and cloudy days.
Sounds nice, but Kepler 452b is a lot larger than Earth.
Kepler 452b is a great Earth 2.0 candidate, but it's sort of like Earth on steroids.
This world is about 5 times more massive than our own planet and about 60% wider.
Scientists call large worlds like Kepler 452b super-Earths.
These worlds are maybe 1.5 or 2 times the size of the Earth, with maybe as much as 10 times the mass.
Could this supersized Earth-like planet be our second home?
A planet like this seems to meet a lot of our standards for an Earth 2.0. It's around a star like our Sun. It's smack dab in the middle of the habitable zone. The problem is there are other factors at play. One of those is simply the mass of the planet.
Kepler 452b's size has an extreme effect on its gravity.
Because of its incredible mass, the gravity on the surface is about twice what we feel here on the Earth.
That extra gravity would make colonizing the planet difficult.
Just about any chore you can imagine doing that you don't like doing on the Earth, you're going to like it even less on a planet like that. When the garbage can weighs twice as much as it does here on the Earth, that's not going to be very much fun.
Maybe LeBron James and I will be okay, but normal humans, I'm not so sure.
And we could be stuck on the planet's surface.
If you landed on the surface of one of these super Earths, it'd be pretty easy to get down onto the surface, but it would be very difficult to get back up.
It's already incredibly difficult for us to leave the Earth. Think of our giant engines and rockets, these incredible miracles of engineering that we need to blast off. You need twice that to get off of Kepler 452b.
And to make matters worse, Kepler 452b's atmosphere is thought to be radically different from Earth's.
In some sense, how big the planet is, how massive it is, will determine what its atmosphere is like. If you have a lot of mass and a lot of gravity, you can hold on to a lot of air.
You can have a much larger atmosphere, much thicker, much denser, and higher pressure at the surface.
A thick atmosphere could trap heat from the star. Surface temperatures become ferociously hot, and crushing pressures make the surface completely uninhabitable.
So it's possible this planet has a very thick atmosphere that's become more of a runaway greenhouse effect. The planet's gotten hotter and hotter over time. Maybe instead of finding an Earth 2.0, what we've found is a Venus 2.0.
Super-Earths may have an appealing name, but their intense gravity would make them difficult to live on, and we could not survive in their thick atmospheres. So far, all the worlds we've found have turned out to be uninhabitable. But what if our new home is not a planet?
Earth 2.0 may not be an exoplanet at all. It might be an exomoon.
We live in a cosmic shooting range where planets die every day. But backup planets like our own seem almost impossible to find. Have we been looking for the wrong thing?
I think there's a pretty good chance that Earth 2.0 might not be a planet per se, but actually a moon of a giant planet.
The exciting thing about an exomoon is that they could potentially be habitable.
So is it possible that as we look at different solar systems, the real analog for Earth 2.0 will turn out to be an exomoon?
(2017). The Kepler telescope scanned a sun-like star 8,000 light-years away, and Professor David Kipping and his team watched the transiting exoplanet, Kepler 1625b.
Kepler 1625 was one of the many thousands of planets discovered by Kepler, but what made it different from our perspective as a moon hunter was that this is a planet which was Jupiter-sized, far away from its star, and apparently on a near circular orbit. So everything that we want for finding exomoons.
The exoplanet Kepler 1625b is an uninhabitable gas giant, like Jupiter. But it is in the habitable zone, and that means its moons would be too. Unfortunately, these exomoons are incredibly hard to see.
The way that Kepler finds exoplanets out there, it really does relate to the size of the planet. And for moons, it's much, much more difficult because it's smaller, so it's harder to detect.
The largest moon in the solar system is Ganymede around Jupiter. It's about 40% the size of the Earth. And we really very rarely detect planets that small. So of course, looking for exomoons is going to be very, very challenging.
In 2018, the team recruited the powerful Hubble Space Telescope and used the data to hunt for the tiny silhouette of any moons.
If you have an exomoon orbiting a planet, sometimes it's going to lead the planet when it transits the star, and sometimes it's going to trail behind as it transits the star, and you see a little bump in the transit dip itself at different places.
And the team detected the signal. Not one, but two objects orbiting together. Confirmation of the first exomoon ever discovered.
It was an amazing discovery. I've been looking for exomoons my entire career. For 10 years, we have been in this quest to try and find these things.
This discovery, this announcement was absolutely remarkable.
Not only does it mean that we might find Earth twins everywhere in the Milky Way, but it gives us something to strive for human exploration.
On this alien exomoon, the skies would be nothing like Earth's.
Visually, I think it'd be an absolutely stunning place to be. You look up in the sky and you see this ringed planet looming huge in the sky.
A world that could be like Earth, only orbiting another planet. But don't pack your spacesuit just yet.
Even though the planet and the moon are potentially the right distance away from the star that we might imagine there being liquid water on the surface, both the moon and the planet are likely gaseous objects with no solid surface to speak of.
Although the moon probably isn't habitable, it is an important step for finding worlds like our own in the galaxy.
If we find exomoons around exoplanets, that potentially hugely increases the number of habitable worlds that are out there.
We just need more accurate measurements, and then all of a sudden, the universe is going to be full of exomoons.
But these worlds need to be more than just Earth lookalikes.
Everyone gets very excited when we find Earth-like planets around other stars, but Earth-like kind of just means how big it is and whether it can support liquid water, where it is in relation to its star.
All of that is great, but it's just not enough.
A planet's composition could be make or break for our new home. The difference between the perfect world and a ticking time bomb. The hunt for Earth 2.0 is still on. We've examined intense red dwarf systems, massive super-Earths, and alien exomoons. But so far, there's no place like home.
There are all these criteria we have to tick off. A sun-like star, an orbit that puts it at about the right temperature, a solid surface, something that could retain an atmosphere.
But a planet that appears Earth-like on the outside may not be Earth-like on the inside.
One of the things that makes our world so unique is its plate tectonics, and that actually regulates our climate.
The Earth's climate depends on cycles of materials, like carbon dioxide and water. Molecules move between the Earth's molten interior and the surface through active plate tectonics and volcanic eruptions. These cycles help to regulate the temperature and composition of the Earth's atmosphere.
If we were to find another Earth-like planet out there and it had geologic activity, that means that at least it has the means to sustain the carbon cycle and all of these natural phenomena that makes this planet habitable and sustainable.
How can we know what's happening inside a planet? A clue can be found in vast ranges across our world. Mountains.
These topographical features are an indicator that the planet is alive and there is still processes happening underneath its surface.
Mountain ranges are created when a planet's tectonic plates collide. And even though exoplanets are light years away, astronomers could work out whether their surfaces are smooth or covered in peaks.
Those mountain ranges are poking out, and depending on which rotation the planet is in, the planet will appear very slightly bigger or very slightly smaller, depending on the silhouette which is being cast.
These tiny changes in light could be the sign that an exoplanet is healthy and active. But we can only use this method when a planet is in front of its star. What if astronomers could use starlight itself to determine the geology of a planet?
We think that planets form at roughly the same sort of time that stars form, and they all form from this same giant cloud of material. And so if you measure the composition of a star, then it seems reasonable to take those values and assume they're somewhat similar for the planets as well.
Astronomers can work out what chemical elements are present in the star by splitting its light into different wavelengths. And any planets around that star will have a similar chemical composition.
Composition is actually a really important part of whether or not it's actually going to be habitable. The composition really is its geology.
Rocky exoplanets are all made from the same basic ingredients. Chemical elements like oxygen, silicon, and aluminum. Change the balance of ingredients, and you get very different planets.
If we have some idea of the composition of a rocky planet, we can actually use that to give us clues as to whether a world has or doesn't have plate tectonics.
New research indicates that exoplanets with too much silicon and sodium form different types of rock than those on Earth, creating rigid planets where plate tectonics stall and carbon dioxide builds up with devastating consequences.
Without active geology, we end up with maybe a Venetian atmosphere.
That means there's a runaway greenhouse effect. It's gotten hotter and hotter, gases are baked out of the rocks, there's no way to actually rain them back out. Not a good place for life at all.
And worse, the planet becomes a pressure cooker, waiting to explode.
If we change the composition of a planet, it affects its tectonic system. That entirely changes how a planet loses heat. And the heat builds up and builds up and builds up, and then maybe there's a catastrophic overturn of the crust.
The solid crust of the planet collapses. Oceans of lava bubble up, and a greenhouse atmosphere boils the surface. A violent end to a potential new home.
Clearly, you need to know about the composition of those planets before you can start making statements about how habitable those worlds truly are.
But there's something else that a planet needs to be Earth-like. An invisible shield that protects it from the dangers of space, providing warmth and life-giving water, an atmosphere. The hunt for Earth 2.0 has turned up plenty of planets. But for a planet to be like Earth, it has to check a lot of boxes.
If you're really looking for Earth 2.0, then you're going to have to find a planet that's the same mass and size as Earth, orbiting a sun-like star at about the same distance, with a similar atmosphere and a lot of surface water that's in liquid form. Good luck.
And on the list of requirements, an exoplanet's atmosphere is critical.
It protects the planet from huge temperature swings. It protects the planet from small asteroid impacts. It protects the planet from dangerous radiation from space and from the star. It is almost literally a shield around the planet, protecting us from outer space.
But it also has to be the right kind of atmosphere. Get it wrong, and the planet can have crushing, boiling conditions on the surface.
Look at our own solar system. The Sun's habitable zone includes 3 different planets, Venus, Earth, and Mars. But Mars has a thin atmosphere and is too cold. Venus has too thick of an atmosphere and is too hot. We're the only planet that happens to be just right.
So far, astronomers have mostly had to guess if these exoplanets have atmospheres. But now, we're looking for them directly. Searching for Earth-like atmospheres around Earth-like planets.
This is incredibly hard to do. So in order to look at the details of these atmospheres, and the glare of the star requires incredibly precise technology and precise measurements.
Astronomers detect atmospheres by watching a planet pass in front of the star. A small fraction of light shines around the edge of the planet and through the atmosphere, where molecules like water, hydrogen, and carbon dioxide absorb particular wavelengths of light from the star.
If we can see the light of the star shining through around the planet, we can maybe deduce some information about, does it have an atmosphere? What are the properties of that atmosphere? How hot is it? What's it made out of?
That's how we'll be able to determine if things in the atmosphere might indicate that the surface is hospitable to life.
So far, we haven't seen any exoplanets with atmospheres that we could live in. But that's about to change. Scientists around the world are working on the next generation of telescopes to revolutionize exoplanet astronomy.
We've got some ideas, and some telescopes that are going to be built probably in the next couple of decades will be big enough, will be sophisticated enough to be able to see this sort of thing.
Missions like the James Webb Space Telescope, 7 times more powerful than Hubble. It should allow us to see the atmospheres of planets across the galaxy and be a tool that finally finds a second Earth.
The key things we'd be looking for in these atmospheres are in the infrared part of the electromagnetic spectrum, which is where Webb is designed to work. The James Webb Space Telescope is, I believe, going to be the next really critical mission to help us in our search for a potentially Earth-like planet.
We're still searching for that perfect Earth twin. And every day, we get closer to finding it.
30 years ago, we had 0 exoplanets. Today, we know of thousands. With the next generation of instruments, we're gonna uncover tens of thousands, hundreds of thousands, even millions of exoplanets.
All with the ultimate aim of leaving Earth, a civilization spread across the stars.
One of the things I love about being a human is the fact that I'm born with this curiosity. This curiosity drives us to explore Earth, explore our solar system, and beyond, into the galaxy.
We'll be learning about these planets for a long time. We have just started this journey.